Thanks, Steve, and hello, everybody. This is going to be very fun. So we have 6 talks. I'm going to jump right in to some fun questions about innovation and about social meaning, and then 2 very fun talks after me will also talk about interesting applications of natural language processing. And then after the break, Chris Manning will sort of back us up and give an overview of the core technologies in natural language processing, things going on at Stanford right now. And then we'll have 2 fun talks on specific applications of natural language processing. So it should be a very great session. So I'm going to start by talking about innovation. Could we use NLP to predict the future of innovations? And we're going to talk about we work on all sorts of different kinds of innovation. I'm going to start with the simplest possible innovation. Look at innovations in words. So we'll just ask, can we predict how words change their meaning over time? And can we use that as a window into understanding innovation more broadly? And I'll give you some other examples. So we know that words change their meaning from Beowulf to modern text messaging. There's lots of ways that the words of English have changed hugely. And by looking at the tendencies or regularities in how these change, we can understand something about how memes propagate, how ideas change over time. And the idea we're going to base this technology on is an idea that many of you know about and that we're going to use in many of our talks throughout the session, which is this idea of the meaning of a word is a vector or a point in space. So if I'm looking for the meaning of the word expect, I might look at how expect appears in some kind of corpus and look at the words that are nearby the word expect. And I can build a kind of vector model of expect where the dimensions are some facts about which words occur nearby or don't occur nearby. And there's lots of wonderful new technologies. Chris Manning will introduce one of them for you later about how to build these vectors. And the result is that a word is a point. I've shown you a little visualization of 2 dimensions. A word is a point in space. And this idea of words as points in space is a really revolutionary idea that underlies all sorts of important technologies that we're going to talk about. And Chris will give you some specifics about one of the vector models invented here at Stanford. So the idea is, given that a word is embedded in a space, a word meaning is a vector in space, we can study word meaning change over time by looking at these embeddings computed from words from different years. So we'll take text from 1900, text from 1950, text from 2000, build word vectors that represent the meaning of words, and look at how those change over time. So for a particular word, let's say the word dog, we build a vector for dog in 1920, we build a vector for dog in 1990, and we ask how have these vectors changed over time. And there's lots of standard metrics we use for comparing vectors, things like cosine and things. And now that we have a granular metric that lets us walk through time and see how words are similar and different, we can actually watch words change over time. So I've shown you 3 examples here: the word gay, the word broadcast, and the word awful. So gay, I'm showing you on the screen the words near the word and the word changing itself with the arrows. So gay in 1900 is similar to words like flaunting, sweet, and cheerful. Gay in 1990 is similar to words like lesbian and homosexual. So the word gay completely changed its meaning over 100 years, and we can watch it walk through semantic space. The word broadcast, interestingly, originally meant to sow seeds. It was a farming word. You broadcast seeds in a field. In 1850, that was the dominant sense of the word broadcast. And of course, as technology changed, and we have newspapers, and then we have television and radio, you can see that by 1990, broadcast is closer to words like television and radio. The word awful, we'll come back to these examples. Awful used to mean solemn or majestic, full of awe, and now it just means bad. So we can watch the word change its sentiment from positive to negative. By doing this, by looking at this change over 200 years for lots of words in English, we can formulate statistical laws of how innovation happens over time, how words acquire new meanings. So I'll give you one of our laws. So the rate of semantic change, that's how fast a word will change over time, is proportional to the frequency of the word, and it's an inverse proportion, so the exponent is less than 0. So the more frequent a word is, the slower it changes. You can think about this as a word like the, very frequent, changes very slowly in English, has a similar meaning to what it had 1,000 years ago. Whereas the rare words are the ones that are participating in a lot of changes. And a second factor in what makes a word change is called its polysemy score. Words that have lots of different meanings change faster. So we can develop these laws of how innovation changes, and we can predict what kind of words are going to change, what words will change the most tomorrow. And I'm going to make you, at the end of this little section, I'll make you a prediction for what word will change its meaning most in the next 20 years. But first, there's an important aspect of word meaning that's very relevant to practical applications, and that's called sentiment. So sentiment is the positive or negative connotation that a word has, and we use this for all sorts of natural language processing tasks, for deciding what consumer sentiment is, deciding if people like a product by their reviews on the web, and so on. And we can measure, we can build lexicons that assign words to sentiment. So here's some positive sentiment words: good, lovely, excellent. But sentiment is also conditioned on the domain. So here are negative sentiment words from Twitter: hate, hated, terrible, nasty, awful. There's that awful again. And negative sentiment when we get it from 10K reports, from company annual reports and things, from companies that have done poorly. Here's the words they tend to use. They use words like down or volatile or negligent. So it's very different words than hate, hated, or terrible. So sentiment is extremely sensitive to what you're talking about the sentiment of. If you used a Twitter sentiment lexicon to try to measure sentiment in finance, you would fail miserably. So we need to be able to build sentiment for different kinds of domains, and then we could track those over time as well. So for example, the word terrific began as a negative word having to do with terror, and it meant, terror. I want to say awful, but it didn't mean awful. It meant related to terror. And I'm showing you on the graph the word becoming more positive over time, and now terrific is a very positive word since about 1955. We can see words go positive. We can see words go negative. So the word lean used to be a negative word. It was very similar to weak. And now lean is much more similar to muscular. You can see how the word has shifted its meaning, and you can watch this trend in concepts change over time. Pathetic was a positive word. It meant passionate, related to pathos, passion. But now pathetic has become similar to weak, so pathetic is gone negative. So we can watch these words change over time. And significantly, 5% of sentiment-bearing words have switched polarity completely from positive to negative or negative to positive over the last 150 years, with, interestingly, it's the negative words that change faster. So this is a huge change that lets us understand how negative sentiment propagates. So lots of implications for very practical applications like sentiment analysis. We saw that words have different meaning in different time periods, but they also have different meanings in different situations. I'm going to show you on Reddit the word soft, and here's positive on the right, negative on the left, sentiment of soft in two subreddits. On the left, sports, where soft is a negative thing, and on the right, My Little Pony, the little kids' franchise, where soft is a good thing. So if you want to do sentiment analysis, you have to be sensitive to the time period, to the corpus, and so on. So I'll just give you a sketch of how we compute this kind of sentiment. We use a random walk algorithm. We take some seed words, and we use word embeddings to find similar words, and then we propagate the sentiment of positive and negative words across this graph. So you can imagine walking across the graph and propagating whether a word is positive or negative to its neighboring similar words. And in the end, you end up with a lexicon that's split, where words have a score for how positive and negative they are. All it requires is a small number of seed words. So we've run this on every year for 150 years. So we know the sentiment for anybody doing historical trends. We know sentiments of words for 150 years. We've run it on all the different Reddit domains. So you can ask about which words have different sentiments in sports versus in finance, and so on. And then, as I said earlier, Chris will talk later today about deep learning ways to do even more interesting things with sentiment. So I promised you that I would tell you a word whose meaning will change. Words change faster if they are low frequency, so if they're rare words. If they're high polysemy, they have a lot of different kinds of meanings. And if they have negative sentiment, it's negative words that change faster. And so we've looked for one such word, and here's the word, infamy. Infamy is a rare, polysemous negative word. So our prediction is that 20 years from now, infamy will mean something else. It'll be more positive, or it will acquire some other unusual connotation. So you can come back in 20 years and see if I got it right. All right, so I used word innovation as an example of studying innovation, but obviously we'd like to see innovation in much more practical domains. So I want to turn to innovation in science. So here we're going to ask, can I predict which area in a scientific field is likely to take off before it happens? Can I tell just by looking at, say, the publications in the field? And so I'm going to describe we have a couple of studies on this, and I'm going to talk about just one where we're looking at words in the abstract. If I write an abstract, presumably I'm highlighting what's important about my idea of my paper. And if we look at how the author talks about the idea in the abstract, could that tell us whether the ideas they're talking about will be successful or fail over time? So here's the idea. Here's an abstract. It's taken from a biology paper in order to address the efficacy of stem cell treatments, neuromotor impairment, rats, and so on. So we're going to start by labeling what kind of sub-areas, what kind of functions are going on in each sentence of the abstract. And we do this by an algorithm called topic modeling. So we're doing unsupervised clustering of the words into topics. So we learned that this green part, I'm colorblind, but I believe it's green over there and red over here. What I'm going to call green sentence is all about stem cells, where the rat sentence is all about animal models. So we unsupervised cluster millions of words and come up with these topics, and then we can label all the sentences in the abstracts for what they're talking about. So now we can ask, well, this paper is about stem cells, and it's about using animal models as a methodology. And now we can ask, what function do these sentences play in the abstract? Well, that first sentence is the objective. It's the goal of the paper. We're trying to understand whether stem cell treatments work for a particular method. And the red rats sentence is a method. It's the methodology we're going to use. We're going to use rat studies to understand this question. So we know what each sentence is about and what rhetorical role it's functioning in the paper. And what we do then is we just label millions of abstracts with exactly these labels. So we know what every sentence is about and how the author is rhetorically talking about it. And we picked 4 fields: biochemistry, physics, chemistry, and neurosciences. And we learned topics for each field, and we built classifiers to label all of the rhetorical functions, the rationales and objectives and methods and background of every sentence in these abstracts. And now we ask, given that I know all this, I have 2.5 million abstracts labeled for all of these functions, can we predict which of these scientific areas is going to be more prevalent in the future and which one's going to die out in the future? So first, we have to find the growing and declining topics. So we just ask for every topic, every sub-area that we discover by this clustering, how popular is it for any given year? And that's 2.5 million curves. We cluster them using an algorithm developed at Stanford called K-spectral clustering to find which topics are growing and which are declining. Popularity just means the number of papers that talk about a topic in a given year. So how excited are scientists in a given year about that topic, because of how many millions of papers talk about it. Yeah, nice. That's an important question. Thank you. Here's 2 examples of popularity changes. So opioid drug research changed over time in this particular time period, dropped a little bit in popularity, while stem cell research just took off in this particular period. So you can see, again, this is just counting how many papers talk about these topics. So this is the kind of thing we'd like to predict. Could we predict that stem cell research was about to take off at the beginning just by looking at how people talked about it? Can we, just from the rhetorical function, how people talk about this idea, predict whether the idea will take off? And the answer is yes. We can pretty accurately predict whether an idea is about to take off just from how the authors of papers describe the idea. Why is that? It turns out that if they talk about the idea as a method, as a new method, or as an important new data source, that predicts growth. People innovating by creating new methods almost always predict that the methods will take off. If you talk about the topic as the result of your paper, the fact that you have found in your paper, those topics decline. In other words, methods people talk about seem to be more important than the results that people find. And this may sound surprising, but it turns out that there's a standard model in the history of science in which natural sciences evolve through methodologies. So it's called rapid discovery science. So this is a lovely slide from David Jurgens, who's about to talk next, where if you look at how people do astronomy, the way they did astronomy thousands of years ago and the way we do it now is completely different in the methods that we use. We're still asking about stars, but our methods are completely different. Whereas if you ask about philosophy, the topics that we talk about in ethics are the same topics that the Greeks talked about a long time ago. So there's some fields, natural sciences are one, where the methods matter, and some fields where what matters is the actual discovery, the ethical principles that we find. And what we're finding is that the scientific topics we looked about are all rapid discovery topics. So here, new methods is what changes things. So we can find innovation by finding people automatically discovering new methods. All right, I want to switch from innovation to talking about everyday language. Because everyday words are something that we use a lot of, studies at Stanford based on understanding people, society, culture, history, based on the use of everyday words, just as we saw in these scientific papers. And because we gave you the language of food book, and because food is just a fun way to look at everyday language, I'm going to give some food examples. So we'll do some data science on menu language. So in collaboration with some colleagues, we looked at words in thousands of online menus. So menus are very available, millions of words in menus. And we looked at how the words in the menus correlated with economic variables. What words do expensive restaurants use? What words do cheap restaurants use? So here's one result. The cheaper the restaurant, the vaguer the words they use, vague positive words. Words of high sentiment, but vague. Delicious, gourmet, flavorful, terrific. They don't really mean anything. They just mean positive. And the cheaper the restaurant, the more they use them. And in fact, you can run a regression predicting the price of a dish from the number of vague adjectives, and you pay 2% in price for every vague adjective. It's cheaper. That's the cheap restaurants. The middle price restaurants, they use a different kind of adjective. They use these very specific descriptive adjectives. That's your zesty, rich, golden brown, crispy, creamy. As you can see, there's lots of them in the $2 and $3, the middle price restaurants. So cheap restaurants use vague adjectives. Middle price restaurants use these sensory adjectives. Expensive restaurants don't use adjectives. So why is that? Why are expensive menus short? And there's a standard linguistic theory about that from the philosopher Grice, who says the reason I would say something is fresh is to inform you that something is fresh. Why would I need to inform you that it's fresh? Because you don't know already that it's fresh. And if you're an expensive restaurant, you don't want your customers feeling like they have to be convinced the food is fresh. You want them to assume the food is fresh, so we just don't say it. So that's the principle, the Gricean principle. We don't say things that we want them to assume. And we can use this as a historical tool, since we were talking about history earlier. So here's the word real on menus. So cheap restaurants, you get real whipped cream, real mashed potatoes, and real bacon bits. Slightly more expensive restaurants, you get real crab and real maple syrup. And then if you look at the really $4 sign expensive restaurants, the word real just doesn't appear at all. So nothing is real on expensive restaurants because everything is real, or that's what you're supposed to think. But then we can use this for a historical tool. So there's a great resource at the New York Public Library where they have thousands of menus for 150 years. And so we can look at the change in these words over time. So here's common uses of the word real on menus: real butter, real whipped cream, and real bacon. So when did they first appear on menus? Real butter appeared in the 1960s, real whipped cream in the 1970s, and real bacon in the 1990s. Why then? Well, 1950 was about when the margarine tax was repealed and the sales of margarine skyrocket. 1960s is when the first popular artificial whipped cream, I won't name its name, was introduced. You can think about it in your head. And 1970 was when the first popular artificial bacon was introduced. So in other words, the word real on menus is a marker 20 years later exactly from the rise of artificial foods. As soon as artificial foods are introduced, somebody claims that their food is not that. So we can use just the rise in the word real as a historical tool in understanding what was going on in the society around us. All right, so that's what cheap restaurants do. What do expensive restaurants do? They use rare words. They use words you might not know, like Bastilla and Persiade. They use long words like decaffeinated and accompaniments instead of decaf and sides. And we can quantify that too because we're data scientists. And so every time you add an additional letter to the average word length, you pay 18 cents more for that dish. All right, so data in the menus around you. And I want to turn now to a second data source about food, which is words on the reviews that people write online. So here's I've shortened it with the dots to fit on the screen, of a long, very negative review from about 1 million reviews we looked at. The bartender, absolutely horrible. We had to wait 45 minutes for our entrees. We had to stalk the waitress to get the check. She didn't make eye contact. We will not return. So really negative review. What do you notice about this review? Long? It is long. It was very long. I had to shorten it. Anything else? Giant capital letters. Excellent. So nice sentiment signs. It's very specific. But specific about what?
The people, not the food.
People, right? There's no mention of food at all, right? No food was harmed in describing this review. It's all about the people. So that got us thinking there's something going on with these negative reviews. So here's what we found in looking at reviews. Negative reviews, not surprisingly, have negative sentiment. They have words like horrible and awful. The same word awful keeps reappearing. They're in the past tense. So we ran a part of speech tagger. They're in the past tense much more often than positive reviews. And they use pronouns and other words about people. So these are past tense narratives about people. And they mention the word we and us far more often statistically than they should by chance. So we were ignored, we flagged down, our waitress, lots of we's and us's. So why would this be? We went to the social psychological literature and asked what kinds of texts display these exact three characteristics. Negative sentiment, like negative, sentimental, past tense, negative narratives about people that over-mention we and us. And we found exactly such a genre. It turns out to be that people who suffer trauma, when they write text, that's exactly what their texts look like. There's a lab that studies trauma in text, the Penny Baker lab at Texas, and they looked at things like blog posts after 9/11 or students who write in the paper after campus tragedy. And the idea is that you use we to seek solace in the community. You use past tense to put this thing behind us. This bad thing has happened, but together we will get through this bad thing. So in other words, these one-star reviews are trauma narratives. I mean, they're minor traumas, no one dies, but it tells you that what you think was going to be a review of a food, of a product, is in fact someone displaying their inner emotions. And you can discover this just by looking at the words they're using in their review. Okay, that's negative reviews. What about positive reviews? Here's some words from positive reviews. Orgasmic pastry, seductively seared, very naughty pork belly. So yes, positive reviews are like sex. But not all positive reviews, only expensive ones. So the more expensive the restaurant, the more likely a positive review is to mention sex as a metaphor. Cheaper restaurants, so if you like a restaurant and it's expensive, you talk about it as sex. If you like a restaurant and it's cheap, here's the metaphors you use. Addicted to wings, like crack, I crave their cupcakes. So your metaphor is drugs. These are like perfect graphs. I couldn't have asked for better graphs. So why is this? Why do you talk about, let's just pick the negative one, why do we talk about cheap food like it's a drug? And we looked at what these cheap foods were, and they tended to be junk foods, right? It's your French fries, your pizza, your chocolate cupcakes. And you're feeling guilty for eating these foods, they're junk foods. And by talking about it as a drug, well, drug is a negative thing, and you feel badly about junk food, but you also feel guilty, and a drug forces you to do something, right? You're under the control of this drug. I had no fault, it wasn't my fault. The cupcake forced me to eat it. So you're sort of eliminating your own agency in having to do this. And we know that women are much more pressured than men in general to conform to healthy eating norms. Lots of research on this. And sure enough, they are more likely to use this metaphor of drugs than men. Suggesting that they are feeling more guilty. Men, by the way, are more likely to write those traumatized one-star reviews. So men are traumatized, women are guilty. That is my conclusion. All right, let me conclude one last little story on food. So instead of, we look at menus, we look at reviews, we can also look at requests when people ask for food. So imagine on the web, lots of people ask for lots of things. People are we're on Sand Hill Road. People are asking for money all the time. How do you get what you want? What language makes you likely to get the thing you ask for? And the problem with studying this as a scientist is it depends what you ask for. If you ask for $1 million, you're more likely to get it than if you ask for $100 million. Well, maybe that's not true, but maybe you should ask big. But we'd like to control for the thing you ask for. And so our idea was look at Reddit. There happens to be a subreddit called Random Acts of Pizza, where all you ask for, everyone asks for a pizza, you write a little ask for the pizza, and either you get the pizza, someone gives you a gift certificate for the pizza, or you don't. And so we have 21,000 requests. We can look at the language people use and see who gets the pizza and what the language is. So here's a request for pizza. I'll just read parts of it. This is a sad request, so trigger warning. My girlfriend and I have hit some hard times, unemployment, she can't do her job, she's petitioning, medical reasons, things are tight, really, so sad story. Let's look at the kinds of things that go on in this. What are the features of this as a text that we could use to predict if they're going to get the pizza? So one is reciprocity. So reciprocity means if you do something for me, I'll do it back for you. Generalized reciprocity means you do something for me, I'll do something for the next guy. And so I would certainly return the favor again when I'm able to reciprocate. That's a good indication of reciprocity. Length. So maybe if you talk more, you're more convincing to people. Evidentiality. So do you present evidence for your claims? So this person gave a picture, a screenshot of their checking account showing no money. So that's evidence. So maybe giving evidence is a good way to get the pizza. Or karma. So Reddit has a thing called karma, which has to do with how much you help the community, how active you are, and we know that people of high status tend to receive help in general. Maybe this affects what happens. And I'm going to just jump to the conclusions. First, that we can predict who's going to get the pizza from the words in the request, and that the most important factor, you'll be happy to know, is pro-social behavior. If you promise to pay it forward, if you say thank you, if you're the kind of person that has karma in your community, you will get the pizza, which is a lovely positive fact about society, given lots of non-positive things going on today in the news. So in summary, hidden in the language of this kind of everyday language, your menus, your reviews, your requests, first, there's lessons even from words that aren't there, right? Luxury advertising is modest. Like the more expensive the restaurant, the less you say. And saying the word real tells you not about the real things, but about the fake things that they don't say are fake. That review words tell you not about the review, but about the reviewer, that your emotions leak into everything you write. And we can learn about our framings about eating as well. And it's nice to know that good deeds are rewarded. So in conclusion, language is a great way to study innovation, and everyday words are a fundamentally cool way to study this kind of thing because we're surrounded by, the web is made of words. We've got words everywhere, and we can study these things. And we can use this for practical purposes, but also to study society, psychology, and economics. Okay, I'll stop there and take questions for a few minutes. Thank you. Oh, microphone, yes. Okay, thanks.
Very interesting talk about your scientific innovation part. So I have a question. So in the scientometric research, they often they use like a citation to study the patterns which a certain topic or has been incrementally amplified. Have you used leverage your words with like a co-citation? Or
absolutely, yes. Great, it's a great question. So the question was, here I'm just going to show you an abstract. This talk, I talked only about using the words in the abstract to predict the future, but we have a whole separate study on using the citation properties. In fact, the person who worked on that is David Jurgens, who's going to talk next, although he's not going to talk about that. But yes, it's combining, and this is a kind of a Stanford thing. It's combining information from network properties and information from words. Turns out to be in a lot of areas the thing that gives you the best prediction. Yeah, nice point.
So two questions. One, in a lot of subjects, there's been the topic of, getting good data is a problem. I'm going to assume by your comment about the internet that's not a problem in your space, or if it is, can you comment? And second, is there anything interesting to say about words in different cultures beyond the obvious? Cultures are different and they have different ideas and stuff like that.
Oh, that is such a great lead into the next talk. So that's two questions. So question one is, what about getting data? Well, it's very difficult. For food studies, so Yelp gives out an academic data set. We collaborate with different people to get data. I've talked to people at different companies about getting data. So some of it is, asking people for data and slowly getting it. Some things are available on the web and you can scrape and look at them. So it just depends on the study. But yes, I would say the hardest part of any of these studies is figuring out what scientific question we're capable of asking with the data we can get a hold of. But often we buy data. So for the scientific, these studies, we bought data from Web of Science. They'll sell you the whole history of science, of abstracts in all these fields. So somebody does collect the data and make it available.
What did you use as the basis of your polysemy score? Like
Oh, great question. So polysemy is polysemy, that's how many meanings a word has, is a really tough thing to measure. So there are online dictionaries. There's one called WordNet, thesauruses that list how many senses a word had. We used instead an automatic metric, which was basically build a graph of how similar words are to each other. So a word is linked to its similar words. And then we say a word is more polysemous if it's the words that are similar to it are not similar to each other. So it's the clustering coefficient. In other words, a word that has two very different senses, the words that are similar to it in one direction will be very different than the words similar to another direction, and those words won't be similar. So it's how similar are my neighboring words to each other gives you correlates very highly actually with the polysemy score. It doesn't require that you use an online resource that's hard to get across languages and times.
One of the problems with the distributional semantics is that it's so dependent on the corpus, right? So how can you accurately compare the language spoken 100 years ago when you use a corpus from 100 years ago to the language now? So can you infer some fixed points, or can you actually map different embeddings across corpora?
Yeah, great question. So in fact, we do both of these things. So when we're studying change over time, we compute embeddings for every year, and then there's various ways to put the 2 years on the same dimension. One is if you use simple models of embeddings where the dimensions are defined by fixed things like words, then in fact so the standard it's called PPMI, the pointwise positive mutual information metric, actually makes every year the same. And so you can actually just compare the years. If you use something more complicated, we use various more complicated metrics. We do something called orthogonal Procrustes. We basically find the linear transform that maps each year most neatly into the neighboring year. And there's a bunch of other standard things people do to find ways to map these things onto each other so you can actually trace things smoothly from year to year. Yeah. Okay, maybe one last question, and then we should go on. And I didn't answer the second half of your question because that's what David's going to talk about, is multilingual and words across languages. Okay. Okay, well, maybe we'll stop here then. Thank you.